guys. So I'm just going to do a quick video on a bit of an introduction to fractions. We have already started fractions, so this might be something that you're aware of. There's a few bits and pieces that you might not have come across yet. So first of all, I thought we'd start off with some keywords that you need to know. These are really important when you are dealing with fractions. Now, usually we'll say to you, or any other child for that matter, we are now going to do fractions. And every child goes, because they think of the word fractions and they panic. Now, fractions is really simple as long as you know your times tables. Fractions is all about your times table recall, both timesing and dividing. So knowing your division recall and your times tables, okay? So, number one, a numerator. Now, you will have come across some of these words before because you have done fractions in previous year groups. You've been doing fractions since you were in year one. You would have started off obviously simply, moving up as you've gone through key stage 1 and 2. So a numerator is the top number. Okay, so for example, with a quarter, this is the numerator. And the numerator is how many pieces have been taken or have been eaten, or how many pieces we are talking about in a word problem. Okay, the denominator is the bottom number. That's how many pieces there are in total. So for example, in this fraction, there are 4 pieces in our chocolate bar and only 1 has been eaten. Okay. The word equivalent means equal to. So you will see this symbol a lot. If 2 fractions are equivalent, it means that they are the same, they are equal. Okay. Right, number 4, simplifying. Simplifying means to make something smaller. So you are making a fraction smaller. Well, you are simplifying it, making the numbers smaller, but they'll still be equal, they'll still be equivalent. Okay? Now, factors and multiples we have done before, so this is something that you may have remembered from a few weeks ago. A common factor is a factor that is common in more than one number. Okay, and that will make sense a little bit more when I show you some examples. A multiple is a number that is in that times table, so a multiple of 2 would be 2. A multiple of 4 would be 16. But a common multiple is a multiple that comes up more than once for more than one number. Okay. Number 7, an improper fraction. Now, some of you may refer to this as a top-heavy fraction. That means that the number on the top is bigger than the number on the bottom. We call that an improper fraction. Okay. Number 8, a mixed number fraction is where there is a whole number and a fraction. So it's mixed. It's got a whole number and part of a number. So that means that we've eaten 1 whole chocolate bar and then 3 pieces out of the 4 of another chocolate bar. Okay. Right, halving comes in handy quite a lot when we're looking at fractions. When we halve and we're dividing by 2. Okay, with fractions we can only halve even numbers. So numbers that come in the 2 times tables. And doubling is when we are timesing by 2. Okay, we are doubling that number. Okay, and we can do that with any number. Okay, so those key words are numbers that you need to know for fractions. I just thought that would be something that would be useful for you before we have a look at some of the questions that I'm going to show you. Okay. Okay, right, this I'm going to start with, okay? This is a number line that you need to remember. It's really important. Some of you may already have seen it before. Most of you will have. It's just remembering it, okay? And we're going to refer to this quite a lot, especially when we come on to doing fractions, decimals and percentages. So I thought I'd quickly show you what this is. So at the end of the number line is 0, okay? At the top of the number line is 1. A fraction is a number that comes in between 0 and 1. So it's bigger than 0 and it's smaller than 1. Okay, because it's a fraction of something, it's part of, that's what fraction means. Okay, so when we're looking at in between, halfway between, we have the fraction a half, because it is halfway between 0 and 1. Okay, so what about these two then? Well, let's look at how many sections this number line is split into. So we've got 1, 2, 3, 4. So it's split into 4, which is quarters. Okay, I'm going to write that here. Okay, so it's split into quarters, which therefore means that we put these out of quarters. So how many quarters would this one be? Well, how many sections have we got there? Well, we've just got the 1. Okay, so that would just be 1 quarter. Which therefore means that this here, there's 2 quarters here. Well, a half is equivalent to 2 quarters. Because 2 quarters simplified is a half. And we'll come on to simplifying a bit more in a moment. So then here we've got 1, 2, 3 sections. That's 3 quarters, which therefore means that the 1 would be the same as 4 quarters and the 0 would be the same as 0 quarters. Okay, so that's something that's really important for you to remember, and we'll actually refer to this again when we look at doing a video with percentages and decimals. Okay, so some examples then of simplifying fractions. Let's have a look at some together, okay? So here we've got 3/12. So what that means is that if we use chocolate bar, we know that Miss Hughes likes chocolate bars, so let's use that. My chocolate bar has got 12 pieces in it, and I've eaten 3 pieces. I want to simplify that fraction. Simplifying means that you are finding an equivalent fraction that uses the smallest numbers possible. Okay, so we need to know our times table facts for this. Okay, so looking at the numbers 3 and 12, think about those two numbers and what times table they're both in. Okay, so this one and this one are both in the 3s. So we are going to divide both of these by 3. So 3 divided by 3 is 1. 12 divided by 3 is 4. So 3/12 is the same as 1 quarter. Okay. Okay, let's have a look at, let's go across here to 25 over 35. And let's think about what times table they're both in. Okay, so straight away, I know that you'll be thinking that they're both in the 5s. Okay, that one's quite an obvious one. They both end in 5, which means that they're going to be a multiple of 5. Okay, so we're going to divide both of these by 5. And the reason why we're dividing, guys, is because the fraction has to become smaller. It's the smallest possible fraction, the simplest term. Okay, so 25 divided by 5 is 5. 35 divided by 5 is 7. So the answer is 5/7. So eating 5/7 of a chocolate bar is exactly the same as eating 25 35ths of a chocolate bar. Okay. Right, so let's have a look at this one then. So 20 hundredths, sorry, the page has gone off there. 20 hundredths. So with this one, we're going to divide straight away. The first thing that you're going to think about is the fact that it can be divided by 10. They both end in zeros, which means that they're both multiples of 10. So let's start with that first of all and see what we get. Okay, 2/10. Now, if you actually look at that fraction, guys, 2/10, it can actually be simplified again. That's not in its smallest form. So this is where our halving comes into play, because sometimes we can actually just halve the numbers. So let's have a look, which is obviously dividing by 2 anyway. So here we are just dividing by 2. So let's divide by 2 and we're going to get 1/5. So 20 hundredths is the same as 2/10, which is also the same as a fifth. Okay, so those three are all equivalent fractions, but this one is the simplest form. That is the simplified fraction. Okay, 24/36. Let's see what times table these are both in. So straight away, you're probably going to be thinking, well, they're both in the 2s. However, they are quite high numbers that are also in a different times table, which is actually higher than the 2s. If you were to put those into 2s, you'd be able to then simplify the fraction again. So let's think about a higher number that they're both in the times table for. So I know that 24 halved is 12, okay? So they're both in the 12 times tables. So if I divide this by 12, I get 2. And if I divide that by 12, I get 3. So 24/36 is 2/3. Okay? So again, look, if you see, it's all about our times tables. We have to know them. Okay? Right, so I want you to have a go at some now. So if I leave that on the screen, you can pause the video and have a go at those 8 questions and see what you come up with. See if you can get them into their simplest form. Okay, so how did you get on? Let's have a look. So number 1, 3/6, straight away, some of you will have looked at those two numbers and noticed that the relationship is that 6 halved is 3 and 3 doubled is 6, which therefore means that that is equivalent to a half. So in its simplest term, it would be a half. Okay? Right, number 2, what times table are these both in? Okay? Well, I know that they're both in the 4s. Okay, so if we divide that by 4 and that by 4, we should get 1/3. Okay? Right, number 3, 6 and 8, what are they both in? So we know that they're both even numbers and that they're both in the 2 times tables. So let's divide them by 2. And you should have got the answer 3/4. Okay, number 4, nice and easy, both in the 10 times tables. We can actually cancel them down and divide by 10, which would give you 1/4. Okay, or you could have done it the same way and put divide by 10, which is the same thing. They both have to end in a 0 for you to be able to do that. Number 5, 2/4, the same again. We know that 4 halved is 2 and 2 doubled is 4, so that would be a half. 15/20, what times table are they both in? Well, they're both in the 5s, so that would be 3/4. You don't have to do the leaps, guys. That's just to kind of help to explain to you. 16/24. Oh, what are they both in? Well, I know that they're both in the 4s, so I'm going to go with 4/6, because 16 divided by 4 is 4, 24 divided by 4 is 6. However, we can now simplify that again. What can I simplify that to? Now that's because they're also, guys, both in the 8ths, in the 8 times tables. So we could have gone a little bit higher because we have to use the highest times table. But it's okay if you do this. I've shown you that for a reason. It's okay that if you do this, that you then decide you want to simplify it again, that's absolutely fine. Okay. Again, 9/12, I'm going to go with the 3 times table, so that would be 3/4. Okay. And guys, in a test, you only need to simplify the fraction if it asks you to. You don't have to simplify the fraction in an arithmetic paper because it doesn't ask you to do it in its simplest form. You can do, or you could give both. So you could give this one and the simplified one just to show that you understand that, or you can just give the one that you get. That's absolutely fine. Okay. How did you get on with that then? If you weren't sure, maybe go back and have a look at the video and see if you can maybe do a few other examples which you could find on the internet quite easily with simplifying fractions. Okay then, so I'm going to finish with this, which is missing numbers. So sometimes with simplifying fractions, you'll be given part of a fraction and a whole fraction, and then you've got to figure out which one's missing and what you've got to times or divide them by. So I know that going from something 8 to 3/4 that we are going to be timesing this number to get this number because we're going that way. Okay, so let's have a look at the bottom one. So from 4 to 8, what have I timesed it by? Well, I've timesed it by 2. So we're going to do the same here and times that by 6. Okay, so that should be 6/8. Right, have a look at this one then. What do you think for this one? Have a quick think before I do it. Looking at the relationship between 27 and 3. What's happened to get from here to here? Obviously, it's got smaller, so we know it's going to have been divided. So what has it been divided by? It's been divided by 9, because 9 times 3 is 27. So we're now going to divide this one by 9, which is 5. Okay, so you should have got 3/5. This one here then, so what have I divided this by? 30 divided by 5. We know it's going to be divided because it's getting smaller. 30 divided by 5 is 6. So if I times this by 6, because I've got to go from here to here to make it bigger, I get what? 9 times 6 is 54. Okay? Everybody happy with that? Brilliant.